Hello everyone, welcome to easyedu, and today we are going to explain the factors affecting the speed of sound wave. This is the part 2 of the previous video. In the previous video we have derived this equation that velocity of sound wave is equal to under root gamma rt divided by m, where gamma is the Laplace correction, r is the universal gas constant, t is the temperature, and m is the mass. And from this equation we can see that velocity is directly proportional to the temperature. Here's the derivation of that equation. This is the initial equation of velocity of sound wave, which is equal to under root gamma pressure divided by density. This mass density, where we know that mass density is equal to mass per unit volume, and volume from ideal gas equation we know is equal to RT divided by P. Substituting this value for rho in this equation and solving, we have derived that V is equal to under root gamma RT divided by M, where from this equation velocity is directly proportional to the temperature. So the sound speed greatly depend on the temperature of the medium. Here is the conclusion: if we increase the temperature, if we raise the temperature by 1 degree centigrade, it will increase the velocity of sound wave by 0.6 meter per second. Now we are going to prove how the velocity of sound wave increase with increase in temperature. From this equation we know that velocity is directly proportional to under root T, where T is the temperature of the air or the gas from which the sound wave is passing. Now let's consider we have velocity V of sound wave at a specific temperature T, and we have another velocity which is denoted by V naught at temperature 0 degree centigrade. Now in this case the temperature is 0 degree centigrade, and in this case the temperature is T. Now by taking ratio of both of these velocities, we will have V divided by V naught under root T divided by T naught, where V is the velocity of sound wave, V naught here is the velocity of sound wave at 0 degree centigrade, T naught here represents 0 degree centigrade, and T is the temperature. Now let's consider T naught is equal to 0 degree centigrade. Now if we take this temperature in Kelvin, this will become 0 degree centigrade plus 273 into K. So in this case we have temperature T is equal to 0 degree centigrade, which is represented by T naught is equal to 273 Kelvin. Now this T is equal to a specific temperature. This can be any temperature but not 0. So we have T is equal to T naught degree centigrade plus 273 Kelvin. Now substituting these values for T and T naught in this equation and solving, we will get T naught degree centigrade plus 273 divided by 273 Kelvin. Now this Kelvin will cancel out with this Kelvin, and 0 degree centigrade we do not need to write it, so we will have the equation T naught degree centigrade plus 273 divided by 273. Now dividing both of these terms by 273 and 273, this 273 will cancel out with this 273. This under root is represented by 1 over 2, and we will have equation in the final form 1 plus T degree centigrade divided by 273, and power is 1 over under root 2. Now this is a binomial equation. Here is the binomial solution, and ignoring the other terms, we only consider these initial terms, which is 1 plus x power n is equal to 1 plus n into x. So the solution of this term will become 1 plus this. Let's consider this is x and this is 1 and this is power n. So we have 1 plus n into x, so n is 1 over 2 and x is T naught degree centigrade divided by 273. Now this 2 will multiply with 273, this will become 546, and multiplying this V naught by both sides of the equation, we will get velocity V is equal to V naught. This will multiply with 1, and also with this term we will have V is equal to V naught plus V naught T degree centigrade divided by 546. Now this V naught here represents the speed of sound wave at 0 degree centigrade, and this is 332 meter per second. So substituting the value for V naught only, in this part of the equation, we will have velocity v is equal to v naught 332 into t naught degree centigrade divided by 546, and dividing this term by 546 we will get 0.6 t naught degree centigrade. Now this is the final form of the equation where v is equal to v naught plus 0.6 t naught degree centigrade. Now if we substitute the value in this equation for degree centigrade for temperature is equal to 0, we will have v is equal to v naught. This is for 0 degree centigrade, which is equal to 332 meter per second. Now if we increase the temperature by 1 degree centigrade and substitute the value of T is equal to 1, we will get V is equal to 332 plus 0.6 multiplied by 1. This term will become 1. So we will have velocity is equal to 332 plus 0.6, which means if we increase the temperature from 0 to 1, then the velocity will become increased by 0.6 meter per second, and the velocity of speed greatly depend on the temperature of the medium. When the temperature is high, the velocity is high. When the temperature is low, the velocity of sound speed in the medium is low. That's it. Thank you for watching, and do not forget to subscribe easyedu for more videos.